Your code has an order, line by line, step by step, but your CPU ignores it completely, and somehow nothing breaks. Every program you've ever written, every app you've ever used, relies on one quiet assumption: that instructions execute in order. First this, then this, then this. Simple, but what if that assumption is wrong? What if the CPU doesn't follow your code the way you think it does? Inside a modern processor, your instructions are not followed. They're rearranged, reordered, skipped, pulled forward, pushed back. And yet, the final result looks exactly like nothing changed. This is one of the most important truths in computing. Your CPU breaks your code's order and gets away with it. To understand why, we need to start with something simple. Imagine your CPU actually followed your program perfectly. No shortcuts, no reordering, no clever tricks, just strict execution, one instruction after another. It sounds correct, it sounds safe, it sounds logical, but it would be painfully slow, because most instructions don't actually depend on each other. Your program might say, load something from memory, then calculate a value, then do another calculation, but those calculations might not need that memory at all. Still, if the CPU strictly follows order, it waits. And waiting is the real enemy. Let's slow this down. Imagine the first instruction needs data from memory, not cache, not fast memory, real memory. That can take hundreds of cycles, hundreds. For a CPU, that's an eternity. So what happens to everything behind it? They wait. Even if they're ready, even if they could run immediately, even if they have everything they need, they wait because of order. And your CPU hates waiting, because every cycle wasted is lost performance. So instead, it does something radical. It stops following your program's order and starts following opportunity. This is where everything changes. Modern CPUs don't execute instructions in order. They execute them when they're ready, even if that means breaking your code's sequence. This is called out-of-order execution, and it changes everything. Instead of blindly following instructions one by one, the CPU looks ahead, scanning, analyzing, searching for work it can do right now. If something is blocked, it doesn't wait, it moves on. It finds another instruction, and another, and it executes those first. Think about that. Your CPU is actively skipping parts of your program, not because something is wrong, but because it's faster. Now imagine this situation. Instruction 1 is waiting on memory. Instruction 2 is ready. Instruction 3 is ready. Your program says 1, then 2, then 3. But your CPU says, why wait? It executes instruction 2, then instruction 3, before instruction 1 even finishes. So instead of 1, 2, 3, it does 2, 3, 1. And here's the strange part. That's completely valid, because those instructions didn't depend on each other. So from a correctness standpoint, nothing broke. But from a mental model standpoint, everything changed. Because now, your program is no longer being executed in order. At least, not internally. And this is where things get interesting. Because once you allow instructions to run out of order, you introduce chaos. Different instructions take different amounts of time. Some complete instantly, some take longer, some are waiting on data, some are already done. So results start coming back in a completely different sequence. Not the order your code was written, not the order your code expected, a completely different order. And now we have a problem, because software depends on order, always. If instruction 3 writes a value before instruction 1, you could get the wrong result. If things are visible too early, you break correctness. So how does the CPU solve this? How does it allow chaos internally, but preserve order externally? This is where the illusion begins. Inside the CPU, everything is out of order. Instructions are flying through different execution units, finishing at different times, competing for resources, moving independently. It's controlled chaos, but you never see it. From the outside, everything looks perfectly sequential, clean, ordered, predictable. So how is that possible? How does the CPU break order and still preserve it? The answer is simple, but incredibly powerful. The CPU separates execution from visibility. Instructions are allowed to execute in any order, but they are not allowed to become visible in any order. There is a boundary, a checkpoint, a final step where everything must be put back into sequence. This is called retirement. This is the moment when results become real. Before retirement, an instruction might be finished, but it's not official. It's not visible to the program. It's not committed. It's just waiting. So the CPU can execute instructions in any order it wants, as long as it commits them in order. That's the key. Break the rules internally, restore them externally. Think of it like filming a movie. Scenes are shot out of order. The ending might be filmed first, the middle later, the beginning last, completely out of sequence. But when you watch the movie, everything is perfectly ordered. That's exactly what your CPU is doing. It's filming your program out of order and editing it back into sequence before you see it. Now imagine the scale of this. Not 3 instructions, not 10, hundreds, hundreds of instructions, all in flight at the same time. Some finished, some executing, some waiting, some not even started, all moving independently, all being tracked, all being managed. And somehow the CPU keeps everything consistent. This is controlled chaos, and it's the reason modern CPUs are fast. Without this, your processor would constantly stall. Every slow instruction would block everything behind it. Performance would collapse. Your system would feel unresponsive, broken. But with out-of-order execution, the CPU stays busy, always finding something to do, always moving forward, always maximizing throughput. But there's something even more important. This system has to be perfect, because one mistake breaks everything. If the CPU commits results in the wrong order, you get incorrect behavior, subtle bugs, data corruption, crashes, and the worst part? They might be impossible to trace, because internally everything looked fine. So the CPU walks a tightrope. It is aggressive, reordering, optimizing, executing ahead, but also precise, carefully tracking dependencies, maintaining correctness, restoring order at exactly the right moment. Now here's the part most people never realize. This illusion is so perfect that developers forget it exists. You write code assuming order, and the CPU gives you that illusion every time. But underneath, it's doing something completely different. And once you understand that, you start seeing everything differently. Performance suddenly makes more sense. Why some code runs faster than expected. Why some optimizations matter more than others. Why independent instructions are so valuable. But also, why bugs can be so subtle. Because sometimes you're not dealing with the order you wrote. You're dealing with the order the CPU chose. And even beyond bugs, this has deeper consequences. Because when the CPU reorders execution, it creates moments where things happen earlier than expected, or later, or in parallel. And sometimes those effects can be observed, not directly, but indirectly, through timing, through cache behavior, through side effects. And that opens the door to something much bigger: security. Because if execution order can be manipulated and side effects can leak information, then suddenly this performance optimization becomes a vulnerability. Entire classes of attacks have been built on this idea, but that's a story for another time. Because the real insight here is simpler. Your CPU doesn't follow your code. It interprets it, it analyzes it, it finds opportunities inside it, it breaks it apart, reorders it, executes it in the most efficient way possible, and then reconstructs it so perfectly that you never notice. All you see is the illusion of order. But underneath, there is something far more complex, far more dynamic, far more powerful. So the next time you write code, remember this: the order you write is not the order that runs. And the CPU is doing everything it can to make sure you never have to think about that. Because if you did, you'd realize something surprising. You're not programming the CPU, you're programming an illusion. And your CPU is doing whatever it takes to make that illusion real.